So let's start with the first question here, 7A. أحمد عبد الرزاق. أحمد عبد الرزاق. Yes, Ahmed. Read this question.
Show investigating magnetism with two bar magnets. She finds that her magnet sticks to some surfaces like the refrigerator door, sink, and the window pane. The magnet did not stick to the window glass, the door, or the wall. What type of material attracts the magnet? Material
Yes.
containing different types of metal, materials that are tiny, materials that contain iron, materials that contain another magnet.
Yes. C. Material that contain iron. We call it ferromagnetic material. Bravo, Ahmed. Next question. And Ibrahim Rabia. Ibrahim Rabia. Khalid. Khalid Al-Isa. Khalid Al-Isa.
Yes.
Khalid, read this question.
Yes.
Here, second question. Read it.
I don't see the question.
You will see it right now.
Yeah. Suki was investigating magnetism with two-bar magnets. What? Investigating magnetism with two-bar magnets. She finds that her magnet stick to some surface like the refrigerator door, the sink, and the window frame. The magnets did not stick to the window glass, the door, or the wall. Next, she decided to investigate their magnetic force. What test could she perform to determine which magnet has a stronger magnetic force? Choose the two that apply.
You will choose only one. Here you have to choose a test that you can perform and you can determine which magnet has a stronger magnetic field. We have two experiments here that can do that. You will choose only one. Read all of them and choose one. Read all choices here and choose only one, Khalid.
Put both magnets on the refrigerator door and test which requires more force to pull it off the door. Put them next to each other and test how much force is required to separate the two magnets. Pour iron filings onto both magnets while they are close together and see which magnet collects the largest pile of filling.
Filings. Yes.
Pour iron filling onto both magnets while they are apart and see which filling arrange into a line that are closer together.
So we have four experiments here. We have four experiments. You just choose one C. You choose C. Read it. Read C.
Yes, C. Pour iron filling into the both magnets while they are close together and see which magnet collects the largest pile of fillings.
So this is wrong. C is wrong. Why? Because if you have two magnets closer together like this, if you see here the magnetic field between them, you can determine it belongs to which one, because it emerges from one and enters to the second one. So you can say it's action-reaction force. So this one here, the force here, or the magnetic force here, is force produced by both magnetic field, for example, by both magnetic fields. It's overlapping magnetic field or interfered magnetic field. So you can determine if they are close together, the strength here, the strength in this point, the strength belongs to the first one or the second one. You can determine that. You can determine that the iron filings here or the strength belongs to this one or to this one because they are close together. So this is not the right experiment that you can do to determine which one is stronger. Pour iron filings onto both magnets while they are close together. When they're close together, the force between them is generated by both magnets, not only by one single magnet. So I can determine this force belongs to which one. So C is wrong.
Mister, did you say my name, Ibrahim? I was
Yes.
late because my internet has a bad connection.
Yes, I said you know. I'm back to you, Brian. طيب, you have another choice, another chance, Khalid. Can you pick up another? But read it carefully. Think about the experiment that you choose, that you're choosing for determining the strength of the magnets, to do differentiate between the strengths of the two magnets.
D.
Pour iron filings onto both magnets while they are apart. Yes, this is right. To see which filings arrange into lines that are closer together. That's right, because when they are separated magnets, when we separate them, those two magnets will be separated away from each other. And when I pour iron filings with them, the stronger magnet will attract more of iron filings and will create magnetic field lines that are close together. So they have to be away from each other, not close to each other, to determine the strength of magnetic field of each one separately. So the answer here is D. This is one. There's another one, and Ibrahim will answer it. Ibrahim Rabi'. If you didn't read the question from the first, read it again, Ibrahim, and choose another one. You have to choose two answers here.
Okay.
Read it loud.
Suki
Yeah.
was investigating magnetism
Magnetism.
with two bar magnets. She finds that their magnets stick to some surfaces, like the refrigerator door, the sink, and the window frame. The magnet did not stick to the window glass, the door, or the wall. Next, she decided to investigate their magnet's force. What tests could she perform to determine which magnet has a stronger magnetic force? Choose the two that apply.
Yes. We have already chosen one, which is D, letter D, and we need to choose another one. You can read all the choices, Ibrahim. The rest, three choices, you can choose one of them.
Okay, I think it's B, Mister.
B.
Yeah.
Read it. Read B.
Put them next to each other and test how much force is required to separate the two magnets.
So if you both magnets, let's imagine these are two magnets, you put them closer together. If they're attracting or repelling each other, this force is generated by both of them, not only one of them. How can you determine which one is stronger if they both are attracting or repelling? You understand it?
Okay, yes.
So you can't determine which one is stronger or weaker by this way. So B is wrong.
Okay, I think it's A.
Yes, the answer is A. Both magnets on a refrigerator door, they are separated from each other, and test which requires more force to pull it off the door. So the one that requires more force to pull it off the door, this is a stronger magnet. So the answer is A.
Mister, can you go back to question one, so because I didn't see the answer.
I can go back. Sorry, no. This is one. Yes, this is question one. Material that contain iron. This is called ferromagnetic material.
Thank you, Mister.
You're welcome. And that's question two. The answer is A and D. And that's question three. And let me pick someone to answer question three. Murtaja. Read this question, Murtaja. Naji.
He was using his computer to model the strength of the magnetic field around a bar magnet. He knows that current parts of the magnet field are stronger than others.
This is a scenario. This is the magnetic field, and this is a question. Where are the strongest and weakest parts of the magnetic field shown in the diagram? You have A.
The strongest is C.
Bravo.
And the weakness is A.
No, not A. A has more field lines as you see.
No, it's D.
It could be D or B. Which one has, more lines beside it? A or D?
D.
I think it's B.
B.
B. So the answer, the strongest C, and the weakest is B. The weakest is B. Let's go to the next one. عبد الله ناصر الملحم. عبد الله ناصر. عبد الله ناصر الملحم.
Did you say my name, Abdurrahman Malham?
You are the next one. عبد الله ناصر الملحم. عبد الله مش هنا. عبد الرحمن will answer. عبد الرحمن الملحم, go ahead. Read this question. Yes, read this question, Abdul Rahman.
Okay. Justin was creating a chart comparing the potential energy between charged particles and potential energy of magnets. Which of the following is true? Potential energy between both like charges are like poles increasing as they move closer together. The potential energy increases between like charge and decreases between like potential energy.
Read them aloud. I want to hear you while you're reading them.
The potential energy between like charges and like poles decrease as they move closer together. The potential energy decreases between the like charges and it increases between like poles and they move closer together. A.
The answer is A. Bravo, Alec. The answer is A. And let me explain it. We have explained that yesterday, and I said we have one rule. If you have to put more energy to the system, that would lead to increasing potential energy. If you had to put more energy into the system. And let me explain A for you. Again, here we have two charges. This is negative charge and another negative charge. And I'm trying, this blue arrow represents that I'm trying to get them closer together. The two blue charges, the two negative charges. So they already are repelling each other, and I have to put more energy into the system. If I had to put more energy, so potential energy would increase. Because of what? Because they already repelling each other, and I'm trying to get them closer. So this would happen what? This requires more force and more energy on the system. Bear with me 1 second, guys, 1 second. So again, I'm sorry guys for interruption. If you have here, let me draw it from the beginning for you so you can understand it. So we have here two negative charges. They already repelling each other, and I'm trying to get them closer with my force. To do that, I have to exert more force and more energy on the system. And the rule says if you have to do more energy on the system, potential energy must increase. So potential energy is what? Increases. Because you can't get them closer unless you add more energy to the system. And this is meaning you adding potential energy to the system. Let's start with two north poles of a magnet. And another north pole. And you are trying to get them closer. They are repelling each other already, and you are trying to get them closer. To do that, you have to exert more force on the system. You have to put more energy to the system. And that means you are increasing potential energy. So that's what the option A is telling us. If you are trying to get closer to like charges or two like poles, potential energy increases. You go back here. The potential energy between both like charges and like poles increases as they move closer together, if you try to get them closer together. So the answer is A. Last question. Let me. Rakan Rashid.
Yes, Mr.
Read question.
Rakan
This question,
Ar-Rashid.
read it. Yes, Rakan, read it.
The magnetic field of Earth acts very similar to a bar of magnet. The magnetic field is created by molten
Molten
iron
iron.
within Earth's core. Humans and animals rely on magnetic field
Rely.
for negative
Relay on. Relay on.
rely
Relay on.
on magnetic
Relay on.
field rely on
Mhm.
magnetic field negation describes how the magnet field is used for negation and explain how it is protects life on Earth.
We have two questions here after the scenario. Describe how magnetic field is used for navigation. This is the first question. We know that Earth has a magnetic field around it. How we can use this magnetic field for navigation? And let me show you something here. That's it. So Earth, as you see, has a magnetic field. How can we use this magnetic field for navigation? The magnetic field, as you see, has a direction like this. This is the magnetic field of the Earth. How we can use this magnetic field for navigation? Rakan, do you know?
Sir Tamim?
If Rakan didn't answer, you can answer. Just wait. Rakan.
Mister, what do you mean by navigation? Like,
If you are,
don't
I'll tell you example.
understand.
Yes, if you are in the dark desert, you are in the desert in the dark night, and you have nothing to know the direction. How can we use? You don't know your directions because it's all the same, and you need to know in which direction you have to be bounded to. So, how magnetic field can be useful in such a situation? This is called navigation, to know your way.
With a
Hmm.
I don't know what the thing is called. That's on the picture.
Yes, that one. What we call it? We call it a compass,
With
magnetic compass. Compass.
a compass.
Yes.
Yes.
So, yes, we can use the direction of magnetic field of the Earth because Earth has a North Pole. This is North Pole, magnetic North Pole.
North Pole.
And this is the magnetic because we have magnetic and geographical. I'm talking about magnetic. Magnetic North Pole and magnetic South Pole has a direction. So if we use a compass, magnetic compass, this magnetic compass can tell us where is the north and where is the south using this compass. So we can use magnetic field of the Earth for navigation to know our directions using what? A magnetic compass. Without this magnetic field, the compass is useless. We can't use it. Okay? Because there is no magnetic field. But because there is a magnetic field, we can use the compass to know our direction so we can use it for navigation. Okay, the second part of the question, Tamim will answer it. Tamim, the second part of the question says, explain how it protects life on Earth. How it protects life on Earth. The magnetic field of the Earth. Tamim, do you hear me?
Sometimes in like dangerous situations, it can help us.
No, I'll give you a hint. Let me give you a hint. You see this picture? It can give you a hint how the magnetic field is protecting Earth. Do you remember this picture before? We have studied before. Tamim.
Yes.
This lines, blue lines represent the magnetic field, and this one, the red one or the orange one, represents solar wind, which is charged particles emitted by the sun. We call it solar wind. So, how, from this one, if you remember how this magnetic field of the Earth protects life on Earth, How does it protect life on Earth?
And because the magnetic field can help us from dangers like the sun rays.
Yes, we call it solar wind. Magnetic field of the Earth work as a shield that prevent or scatter or deflect the charged particles emitted by the sun and deflect it away in the space away from the Earth. They can't reach the Earth. That's why, but in other scenario, if this solar wind or charged particles were able to reach to the surface of the Earth here in this point, it will damage the life on Earth, completely damage it. So we can think that Allah subhanahu wa ta'ala created the Earth with this magnetic field for many reasons. One of these, for many benefits, one of these benefits, that it deflects away the harmful radiations that we call it, that's called solar wind, which is a charged particles deflected away from the Earth. Because of these charged particles, if it reaches to the Earth, it will damage the Earth. So the answer here, this is explanation, the answer here is only one sentence. The magnetic field of the Earth, the blue lines here, work as a shield that protects Earth from harmful radiation emitted by the sun. This is the answer. I'll say it again. The magnetic field of the Earth work as a shield that protects Earth from harmful radiation emitted by the sun, which we call it solar wind. Okay, let's go for, thank you, Tamim. Let's go for the next lesson 3. We still have 10 minutes, so we can solve a bunch of questions here. And Tamim, you didn't answer this question, so you can start with the first one here to answer it. Tamim?
Yes.
Read this one. You didn't answer the previous one, so answer this one.
Tamina is presenting an electromagnetic at the upcoming science fair. She is using wire, a nail, and a battery. How would this electromagnet work?
Yes. Read all the choices and the big one.
The wire creates a loop between the nail and battery, turning the nail into a magnet where current flows. The wire loops the nail to the battery so that the current can flow directly into the nail, creating a magnet. The wire loops around the nail, which becomes magnetic when the current flows from the battery through the wire. The wire loops around the nail and the battery, turning the entire system into a magnet.
Mm-hmm. So how
It's
can we
C.
create? Huh?
Is
Yes.
it C?
Yes, is it C? Yes, it's C. And that's the electromagnet. I'm going to show it to you. It's here. I think that I have it here. So it's something like the previous one, but it's like, it's all this electromagnet, by the way. But this one is good. So you can think this is a nail, this one is a nail. And this is the wire that carrying a current. When the current flowed through the wire, which is looped around the nail will be a magnet, temporary magnet or electromagnet. So that's how we can create electromagnet. We loop or turn the wire into a coils or loops around the nail, and when the current runs through the wire, the nail will be a temporary magnet, an electromagnet. So the right answer for this is C. The wire loops around the nail. It means coils around the nail, makes coils or loops around the nail, which become a magnetic. This which belongs to the nail become magnetic when the current flows from the battery through the wire. So the answer is C. Thank you, Tamim. Let me take another one. Laith. Let's take from the top. Abdulaziz Badr.
Hello, Mr.
Abdulaziz, read question 2.
I read when is constructing an electromagnetic to demonstrate as the upcoming science fair. She is using wire nail and the battery. She is using identical material to create three different electromagnets of varying strength. How can the same material be used to create a strong magnet?
So he's asking about here, how can you make a stronger magnet? And they give you a multiple or a bunch of choices here. You have to choose which of these would increase the strength of a magnet. Read all of them and then choose one.
Add more wire in between the battery and the nail so that more current can flow. Place less wire in between the battery and the nail so that more current gets to the nail, and more loops of wire around the nail to increase the magnetic field. Drop fewer loops of wire around the nail to increase the magnetic field. See, Mr.
Bravo, Alec. Because we can increase the magnet by two ways. Number one, increase the loops, and that's what is written here. And the other way to increase the current itself. If you have the same material, if you have the same iron inside the loop, like this one. So assume that we have this material. This is iron, this one. And how can we increase the strength of the magnetic field? You have two ways. Increase the loops, like here. Increase more loops. You add more loops to this one, like this. Adding more loops will increase the strength of the magnet, or increasing the current passing through the magnet. These are the two ways that it can increase the strength of a magnet. Add more loops of wire around the nail to increase the magnetic field. He only mentioned one here. Question number 3. Let someone to read it. Just 1 minute, guys. Abdullah Khalid Al-Husseini, read it. Abdullah Khalid.
Yeah.
Read this question, Abdullah. Abdullah, do you hear me?
Hello, Mr. You hear me?
Just 1 minute.
Okay.
Read this question because this one will take a little. This one, read this one.
Okay. Terence is comparing information about
solenoids and electromagnets.
Solenoid and electromagnet for class project. Read each phrase and determine if a resistor, either a solenoid or an electromagnet. Drag each phrase into the correct box.
First one, you will do the only first one. Has a ferromagnetic core. Electromagnet. You put a nail, ferromagnetic nail. Thank you. Yes, Ahmed Al-Atibi. Ahmed Al-Atibi is here. I think he's excused from yesterday. Ahmed is here. Okay, Ahmed, second sentence.
A short loop of used in MRI machines. Sorry.
Created from a stacked loop of wire. Yes, this one belong to what? Solenoid.
Yes.
Yes, it consists of loops of wire. Okay, because we just wanted to have, it's similar to this one, but this one is used to create a magnetic field. This is called electromagnet. It has an iron or ferromagnetic core inside it, so to increase the strength of the magnetic field. Solenoid similar to it, but without this loop, created from a stacked loop only of wire. So this one is solenoid. Let me pick another one. Let's go down. معا and this one, if each has the same, or read any one of them and put it here.
Each has the same number and tightness of loops. This is stronger. It's for electromagnetic.
طب used in MRI machines, used for what? Magnetic resonance imaging machines. This is the abbreviation, MRI. Which one is used in MRI?
Electromagnetic.
Electromagnet. This is used in
Yes.
MRI. Okay. So if each has the same number and tightness of the loop, this is stronger. So it means if you add more loops to it, this means that that is stronger. If each has the same number and tightness loop, this is stronger. If each, he mean by each here by solenoid and electromagnet. So which one belongs? We put it where?
Solenoid.
No, if you have solenoid and magnets, and they have the same number of loops, okay, and tightness, the same number of loops. They have the same number of loops, and you have an electromagnet and you have a solenoid. Which one will be stronger, the solenoid or electromagnet? And why?
The electromagnet.
The electromagnet will be stronger. Yes, because it has what?
Because it has more.
It has iron core. It has
Yes.
a ferromagnetic core, and this will strengthen the magnet. Okay. I think this one used in MRI, I want to be sure from it. It belongs to here too, but I think it belongs to here. You can see it later. No problem. Oh, this is the last question. We have less than 1 minute to answer it. And who didn't answer yet? Faisal? Faisal,
Yes.
read this one.
There is creating list of the possible ways that the strength and electromagnet can be
Altered.
altered. Which of the following should Kira not add to her list? A. Adding an insulator to the electromagnet. B. Creating the wire loops. C. Changing the current in the wire. D. Spacing out of the existing wire loops.
So what's the right answer? All of this can change the strength of magnetic electromagnet except one. Can't change it. Or does not affect it.
Adding an insulator to the electromagnet.
Bravo, Alec. Adding insulator. Thank you guys for listening. It's 1:56. This is the end, and I see you next week. Have a nice weekend.